requirement of the vegetable transplanter, and then the agronomy, which is essential as a scientific one. So I will request to connect with your team and then let them join this session. If anyone is facing any challenge in joining, let us know initially only, so we can solve it, and then we will start from the content which we have for today. And Aisha, I think you started the recording, so we are good there. Yeah. My voice and video is clearly audible and visible, right?
Yes, Nihal.
Okay, yeah, thank you. Okay, so I think we can start here, and meanwhile, other can join. If anyone is facing any issue, just let us know in the chat, and then our team member from OC can help you to join. So, just 1 minute. Is my screen visible to everyone?
Yes, your presentation is clear.
So, okay. So, thank you for joining. As we know, this session is for overview of vegetable transplanter, where we will cover some specific agenda, which is mentioned in the next slide. So, this is the agenda for today. So, I will request Mayuri to take us from the agenda which we have today, and then later I will start from the outlet system for the tech time.
Yeah. Thank you, Nihal. So, good afternoon, teams, and we will start in this today's topic. We will go through the agronomy of the crop for the chili, brinjal, and tomato that we have our in rule book that we are making our implement. So, what is the agronomy of the crop? Then methods of vegetable transplanting that we use generally. Then tractor power outlets that is through from the linkage system we will study that is cat1 and cat2, and we will study the PTO and ground wheel output advantages and disadvantages.
Okay. I will request student another member to please keep on mute. If any question, you can put on chat, and later once the session we are done with the content, we will take the questions in the end.
Then we will going to study automatic transplanter subsystem overview, and at the end we will take a question and answer session. Audible to all, or any disturbance is there?
Your system is, you are audible actually. Can we make all of them mute then except yourself?
Yes, just let me and Mayuri unmute, and the other can be muted.
Sure, okay.
Okay, thank you.
So,
First topic that we will do, that is agronomy of the crops. So we will study here. You, as you most of the from the farmer background, will know about this, but the students which don't have awareness, so we will go through the what are the different stages crop grows and land preparation goes to develop any crop. So first stage is the preparation stage. So we usually prepare our land for the primary tillage by MB plow, and then we will for the manual compost we do spreading, and then we do the fertilizer broadcasting after our primary tillage, and then for the secondary tillage we will use the rotary tiller, cultivator, or harrow. And after that by wooden leveler or blade. This will be the preparation of the land phase. After that will be the where stage comes where we do the planting. We do the planting sowing by manually, or we use the planter. Then once we implement sow the plant, then there will be the another stage to protect the plant. So that we can do weeding. That there is we can do the weeding by manually, or we can use a weedy side, or by using the tractor. We do the weeding. Then for the fertilizer broadcasting, that mostly we do the manually. Then for the pesticide application, we can do the by manually or by tractor spraying. And then for the irrigation, we can use the sprinkler, drip, and manual, or we can do manually. Then after the this stage, the once the plant grows and we do the harvesting, so we do the digging. That can be also done by mostly manually.
Hello.
Hey Nihal, yeah, I can hear you. Sorry for the inconvenience, please.
Okay. Yeah.
Yeah.
Student, sorry, there is some error in the meeting link which is created. We will start with the point where we dropped. We will start with the pickup system. Just 1 minute. Okay. I'm sharing my screen. Just let me know if you can see.
Yeah, we could see you.
Okay. My screen is visible.
Yes, now it is visible.
Okay. Yeah. Thank you.
I think let other students join because
Okay. Yeah.
everyone.
Uh,
Yes, Nihal, we can get your presentation. Yes.
like the subsystems which need to be placed on the machine. So this is just the flow where we need to understand from the sapling tray we have the pickup, then we have holding and transporting, and then when it is picked, it is conveyed to a digging system which will be conveyed to the transport system which will be provided on the machine. And for the entire operation we will have some powered shaft which may be attached to the ground wheel, or there may be a electrical operation where motors are provided along with the battery, so that is also some kind of subsystem which can be provided on the machine. This is just to give the rough idea how we need to understand on the envelope, and then how we need to place our component, and based on that we will decide our equipment, and based on that we will decide our machine. So this is specific to ground wheel. Only important point is we need to maintain this ground height from the ground, because the height of the bed or the ridge which is in the field, that is about 150 mm. So this height should be like more than that when the wheels are on the ground. This height should not touch with that bed. So while designing we need to keep this parameter in mind. Now uh, we talked about like the overall requirement, then the agronomy of the conveyor there. Now talking to specific subsystems which are like the critical heart of the machine, and then for the automatic system we have the picking system, which is the most valuable system, and where like most of the R&D need to be done. So pickup system, if you see like there will be some specific metric dimension tray. Yeah, specific metrics of dimension tray where we have like 104 cavity, 8 into 13. So this direction it will be an 8 cups, and then the 13 cups in this way. This match with some picking mechanism that may be automatic through electrical system, some motor or controllers may be there, and then it may be an mechanical system which will help to pick the plant. But the thing which we need to keep in mind is like the size of the tray, or if it is customized one, we need to follow the rules which are mentioned in the rule book. And then while designing, we need to understand the key point, which is like compatibility. Is it compatible with three crops, which are chili, brinjal, and tomato? It should be able to maintain the variable speed when it is picking, and then when it is transporting or maybe conveying it to the other system. And then how many sapling tray that implement can hold, because when you see the field diagram where there we have some kind of spacing requirement, and for the specific length we need to run, there will be a requirement of saplings which need to be there on the machine. So you should understand how many saplings will be there on the machine and how the movement will be controlled for the pickup. Then how the trays are held on the implement, it may be some kind of horizontal placement, but you need to understand how that operation will be like completed while the pickup is required at the machine or at the specific location. Then design of mechanisms for sapling pickup. So this mechanism, as I talked, like this may be an electrical system or maybe a mechanical system, which is based on the the ideas you have, and then you can rate it like what are the positives and negative for that specific mechanism. Selection of the transmission, which we have shown in the rough sketch, but yes, the power source will be depending on the mechanism which you select. Now, coming to the picking mechanisms, this is just high level, but yes, there are different kind of pickup systems available. And if we talk about like the highly used one, or which are mostly used in our machine, which are currently available, first one is pin type pickup. So pin will pick the sapling from the cup, and then it will place it into the machine. So if you see like this kind of round shape cups which will have the sapling like placed into the cup, and when you need to pick it, we have the some kind of pins which will move in the direction through some kind of rocker arm and electrical controlled motors, stepper or servo motors, which will dig into the soil along with the roots of the sapling, and it will move it into a forward or top direction, and then it will convey the plant into a conveying system. And then we have the push mechanism. So if you see here, like this is kind of rocker arm mechanism which is moving, and then it will provide the translatory motion in this direction. And the plant which is there, is in the original location, and when the tray is moving, then the tray will have specific plant location. When it will come, it will detect through some sensor application, and then it will pick the plant in the translated direction and drop it into a conveying system. So this kind of mechanism will be there, where we will have the pull to the conveying system. Then we have the gripper mechanism. So gripper is like the electrical system or maybe a mechanical system where you will grip the plant through the stem. So if this is our plant, we have the stem which is there in the center, and then that stem can be holded in this location where you can grip your plant, and then once it is gripped, there will be some horizontal or vertical motion of this mechanism which can withdraw the plant through this system or next system. This is a high level different kind of picking mechanism, but based on the subsystem which you have selected or based on the mechanism which you have decided from the power source, that may be hydroelectrical or maybe the mechanical system, you need to select the mechanism for the picking, where you may grip, push or pin type mechanism will be there. So you can pull it from the soil or directly pick it from the stem. Now coming to the conveying system. So once operation which we need to do or for which we need to design our system is the conveying system, where we need to get the plant from pickup and give it to a digging system, where the digging will be done into a soil. So the first question which comes here for design is how saplings are being conveyed from the sapling tray. There may be some kind of PTO operation which is giving the rotatory motion to the conveying system, or maybe through the ground wheel, or some electrical motors are provided convey the plant to the digging system. So the thought which we need to take while designing the conveying system is like the maximum number of saplings with no or minimum damage, because if sapling is transplanted with some kind of damage, or if the roots are damaged, then even after conveying, it is not like it will affect the overall productivity in the field. So we need to understand the number of saplings which are picked. Along with that, we need to understand how our sapling are getting damaged, because if it is some kind of vertical system, out of 104, there may be a chance like 50 saplings dropped without any operation, they are damaged, so that is lost to the farmer or end customer. So we need to understand that. Then the second thing is proper picking of sapling from tray and bucket, and thus ensuring a smooth transfer when you are picking the plant and when you are transferring it to a conveying system. One thing which we need to keep in mind is the location when it is picked, and the location where it is dropped, because if it is like vertically down or it is tilted, then when it will go to a digging system, it will affect the further operation. So that conveying should be smooth, and then it should maintain the proper placement. Along with that, channelized pickup system toward digging. So like operation which is there after conveying is digging only, so we need to maintain that proper channel, how it is transferring the plant, and then how smoothly it is providing it to the digging system, so that it can be easily located into the soil. Then choosing an appropriate conveyor belt. So this is like when you are talking about the saplings, because it is like 10 to 15 centimeter of height, and then if it is damaged, then it will be a challenge. So proper kind of conveyor along with proper angle need to be maintained, so that there will be no damage. And then the flow rate is obviously related to the spacing requirement, so you need to vary that spacing for different crops, what we discussed in the agronomy. So that provision should be there. When the pickup is speed is changed, your conveyor all these parameters come with some power, which will be a power consumption. It may be through the electrical or any other system which you have selected, but that power consumption for the conveying unit should be like and in some ideal range, or maybe that is acceptable range. It should not be like the entire system is consuming some power X, and then the conveying system is consuming more power than the any other system like digging and picking system. So that power consumption should be in maintained. that to the conveyor, like what kind of conveyor you are deciding, but yes, that should relate what diameter we are providing in the sapling tray. Now coming to the digging and covering of the soil. So once the plant is conveyed through the conveyor, there will be some kind of digging mechanism which will dig a hole, and after digging, that plant will be placed. Along with that, we have the covering system which will cover the roots of the soil. So specific to digging, we need to understand the geometry, because if this shape is not good for digging the soil, then it may cause challenge in digging a hole, and then the plant will not be placed at proper depth and or at the proper location at the center of the hole which is digged. So this geometry is very important. So when you are designing, just understand the size of your plant, size of your soil which is mounted onto the root of the sapling. So that you need to take care while the geometry of the blade which is digging into a soil. Then material is also important because it is coming in contact with the soil. So you need to understand which material is like more resistant to soil or the moisture conditions which are there, or some other uh, particles, or maybe the corrosive materials will be there. So you need to make that hard material which will easy to dig. Then the rack angle, throat angle, and draft. So this is related to the placement, because once it is digged, you cannot place a plant exactly at the same time when it is digging. You need to place a plant at about like 5 degree or 10-degree angle when it is moved by 5 degree or 10-degree. Why? Because if it is at the same depth, then when it will move through that hole which is digged, it will damage the plant, or it will tilt the plant, and then covering system will cover the entire plant, which is also a damage in the field. So we need to understand that rack angle where the plant will be dropped, and then the throat clearance, that clearance which is maintained while dropping, because that is required even in the transplanting condition. Then coming to the draft calculation. So this is the overall power required. How we calculate it in the pickup and conveying. Here also we need to understand what kind of force is coming when it is moving in the horizontal direction attached to the tractor moving forward. And then the depth adjustment. So when we talk about the crop, different crops have different depth requirement. It may vary from 7.5 centimeter to 12 centimeter of range. The different depth requirement in the digging system. Along with that, there is a requirement of closing mechanism. This closing mechanism is required to maintain the covering of roots, because once the transplanting is done, there may be a sudden shock from environment, or maybe some insect may damage the crop. So you need to properly cover the roots. So if roots are covered, then there will be a less chance if that plant will get damaged. There will be a lot less shock. In terms of agronomy, it is transplanting shock. So we need to maintain the cover of soil or over the roots, so that there will be then for operation overview or the subsystem overview. This is just a high level subsystem which we have discussed, from pickup, conveying, digging, dropping, and you can design your own mechanism based on the requirement. If I just summarize what we need to keep in mind while designing a system, first is the customer requirement, which is driven through the agronomy. So yes, as an Indian farmer, we have a tractor which should So Cat 1, Cat 2 is one thing which we need to keep in mind while designing. Then with this, we need to understand the transmission which is required. So the transmission may be ground wheel, that may be a PTO driven, and maybe some electrical system provided over there. Then through that transmission, you need to understand the agronomy, like what spacing you need to place the plant, maybe chili, brinjal, and tomato, and then how much plants are required, or the saplings are required into your machine to perform for like 25 minutes while maintaining the system. Talking about the individual subsystem, like the pickup. So pickup should be synchronized. It should be easy to operate or function, like reliable one. Not only like it is functioning one time and then plant get tilted, or it is in revert direction. So that parameter need to be maintained. It may be electrical, it may be mechanical. Then for the conveying, the important parameter is type of conveyor and then how much power it is taking in the entire system operation. Then through the conveyor we have digging. So for digging, the important thing is yes, for the conveying mechanisms, for the digging mechanisms, important thing is the depth. So you need to have some adjustment to adjust the depth in the soil, and then the geometry of the blade which you are selecting for the digging mechanism. So that two parameter you need to keep in mind while designing. And then we have a specific requirement for covering system. So that covering system should be like, it should not cover the plant, it should cover the roots. So that system should ideally with some clearance moving or maybe along with the plant in the transplanter. Now coming to the integration of subsystem, you can see like how ideally the machine can be, but yes, the subsystem will depend on how you are designing your mechanism and then how you are placing as per the transmission or the power source available. It may be from PTO, it may be from the ground wheel, or it may be some electrical or hydraulic system placed over the machine. This is like a feature which is pick up picking the soil and then moving it into a vertical direction at some angle. Then we have the conveying mechanism, which is rotating, and then it is dropping a plant at particular location so that it can go into a digging system. Then from the digging, we have some kind of opening at particular angle so that the plant can be transplanted into a ground, and then some kind of covering mechanism which will cover the root. So this is the ideal system, and based on that we need to understand like different subsystems have different requirement, and we need to design our own system by calculating the different parameters which are critical for the design and also for the functionality. So with that we can move to Q&A, and any questions you have you can put into a chat, and then we will just see.
There is question. Is it okay if I don't use a conveyor belt for conveying system and use any other mechanism for conveying? Yes, you can use any system to convey the plant to the digging system. We have just showed the examples here. For any specific, it is not recommended to use the specific systems that we have shown here. So you can use your any system to perform the basic functions. If the tractor is stopped but the machine can run because of the PTO rotating, then machine damage. Yes, it is true that if the tractor is stopped, PTO still can run and it can still drop down. It will perform its function of the dropping down the plants, but it will not damage the machine. So you need to see while using the PTO. So this is one of the disadvantage of the PTO. You need to see from this, you need to use the PTO or go with the ground wheel.
Yeah, and adding to this point, like when we are talking about the PTO attachment to the tractor, uh, when we are taking a turn in the head or at the dead end, when we are taking a turn, we need to have some kind of mechanism when you are lifting a tractor that PTO should get stopped. There are some accessible systems which are currently getting used in the rotavator. So that mechanism need to be there, and that's why we say like PTO have some kind of complexity. But yes, if you have idea how to stop it when tractor is stopping, that PTO should get disconnected with your transmission which is there in your machine. So that kind of provision should be there, and then only PTO application will work for the transplanting operation.
So can you please explain plant to plant distance again? Can you go to the slide, Nian?
Okay. Okay, so we can explain on this.
Yeah, so here if you can see, we have 3 types of plants that need to be planted by implement, that is tomato, brinjal and chili. And in the rule book, the minimum distance that we have specified here in the PPT, that is for the chili, it will be 300. For the tomato, it will be 450. And for the brinjal, it will be 600. So C distance will vary according to the plant. And your implement should be able to do that. We have just explained in the earlier slides why for every plant in agronomy it is recommended. This is the recommended distance that we have taken. So for that, for the growth of the plant, so this is the standard distance for any plant, and that you need to implement in your implement.
Yeah. And this, okay. I think this question is not clear. Sudhir, can you please type it again for digging system used to funnel? Yeah. I think before this, we have something which communication team need to share as a survey. So, Snehilata or Pooja, hello.
Yes, yes,
Yeah, so
yes.
you can share it first and then we will take the questions.
Yeah, sure, sure. Students, we have already floated and survey for finalizing the list of the students. So please make sure like your list is finalized for the students. You will have to submit the final list by 30th September. So it will not be, the date will not be extended because it's all been around 1 or 2 months since our registrations are closed. So please make sure you are completing the sending out the list of the students by 30 September. And I'll just quickly share onto the email. So those who have not received the email, please don't worry. Like we will just share you like share the link onto the WhatsApp as well. So and this we are doing because we want to get the email IDs of all the students so that no one is missed from over here. So you will have to fill the team name, team ID, the college name, institute, then the official email ID that I hope everyone has created it in this form, that is Tiffin26 team name at the rate gmail.com. Your team name over here, captain details, vice captain details, the details for the faculty advisor. Then please make sure we want to make sure like if you have connected with the assigned mentors, and also the captain, vice captain, and the faculty have been added into the WhatsApp captains group. If yes, then please choose the options over here, and here you will need to add the attach the list of the final students over here, the name of the faculty advisor, the students, in the form of Excel. So only the Excel format would be accepted over here. So please make sure you are uploading the file of the students over here. And please do it before 30 September. Okay, that's all was the update from my end. Maybe if I'll share the link after this meeting in the captain's group as well, so that everyone is able to complete it. And make sure like you're typing the correct email ID, because what we observed is in the list which you have already filled there somewhere Gmail spelling was not correct, like it was GAMIL. So please make sure like the email ID you are writing is correct email ID, because moving forward we will all send all the details onto the email ID which you are submitting through this survey. So please do that. Please make sure you are sending the correct details over there.
Ma'am,
Yeah.
I'm from Team SGGS. This time we are
Oh,
participating for first time. Can we get some more time to finalize team?
no, actually, we are already like we will already begin the sessions. We have to plan on to that. So I we like we, even we shouldn't give this option, because at the time of registration only the team is finalized. But we are giving this to modify the student count. So please finalize the student count by 30th September. We already have 5 to 6 days, and we are already iterating this since last few sessions already. So yeah.
And ma'am, it's a finalized list or can you modify it after?
No, after this, no modifications would be accepted. That's what I'll say again and again. And in the rule book also, we have mentioned the same thing. Nothing would, unless and until there is some worst case, like due to some unavoidable reasons, the student have to leave. So only in that case, in it will be accepted, or else no acceptances would be there in further. No change in the team.
Okay, ma'am.
Okay. Yeah. Thank you. Yes, Nihal, you can. uh,
The question mechanisms to control the PTO in the tractor provided by the TIFAN. So, there will be a mechanism, but the changes into a mechanism for the tractor is not acceptable because it is equal to all. Only changes will be allowed in the implement. Once you are attached through the 3-point linkage and then PTO, and you are starting for the evolution for the 25-meter run, no changes or the variation in the tractor side will be done. So that is one specific point which we need to understand while taking the PTO power. Okay. Yeah, but there are some other points which we need to consider for the PTO, and maybe we can take in upcoming session. If it is giving the power through the PTO, and if there is specific lever available on the tractor, we will discuss this with our expert, and then we will provide a specific section in the rule book for the PTO specific design. So for now, you can consider there will be no provision on the tractor. Uh, if it may be hydraulic or it may be for the PTO operation. So directly an outlet which will be connected, and then operator will be from SAE side only. But yes, further details we will share. Okay. So I think we have 2 more minutes, and we'll take the couple of last questions.
Excuse me, sir.
Yes, Varun.
Sir, in the rule book, tractor speed is 1.5 to 2 kilometer per hour. But John Deere tractor official website, there are lowest speed of tractor is 2.8 kilometer. So what we consider?
So you can consider in the rule book, but if you can going by the PTO, you will have the 540 RPM, whatever the speed of the tractor. So that's the RPM you will need for the further calculation. So you can consider the 540 RPM for further calculation of the for the PTO. And anyway, ground will be driven by over the ground speed. So that speed you can use 1.5 to 2 kilometer per hour for the calculations. Is the answer clear?
Yes, ma'am.
Yeah. Is it feasible to utilize ground wheel mechanism as a power source to drive the chain drive and transplanter mechanism to the mechanical transmission from the wheel rotation? Yes, it is feasible. The rule book is Tejaswini is available on the SAEINDIA 2026 page. You can download it from there. Nishikant, what is your question? We can use the funnel for digging system. Digging system is the requirement for the implement, that will be the automated from and driven by the our in implement automatically. So in any activity we cannot do from this manually, if that is the question. So I think all the questions we have covered. So if any question is remaining, you can ask it here directly.
Yeah, if no question, I will take one point like for the PTO operation, we will share more details, which is specific to like the controls which will be applicable or maybe which will be allowed for the adjustment of the PTO when it is taking a turn or maybe when it is performing an operation and suddenly stopped. So then we will check with our the textile expert and then we will let you know the details. Along with that, we will update the details in the updated version of the rule book. For now, you can start designing your subsystem. And for the PT operation, we will share some more details in the upcoming sessions. Thank you for providing time. And if you have any query, connect back to us in WhatsApp or maybe through mail channel, which is provided by the communication team. Thank you.
Thank you all.
Yeah, thank you.